Welcome to the Gage R&R Auto-Tolerance Tool, an easy-to-use, browser-based screening aid designed to quickly assess your measurement system's risk against ISO 2768 tolerances. By simply entering 4 repeatability trial readings on a feature, this tool instantly calculates what percentage of the ISO 2768 tolerance your gauge is consuming. It's important to understand that this tool is meant as a preliminary screening aid, not a full replacement for a detailed AIAG measurement systems analysis study. The tool itself displays a clear note stating this. However, it's incredibly effective at catching obvious issues, like a worn micrometer or a fixture with too much play, in mere seconds, saving you the time and effort of scheduling a formal study. Built as a single HTML file, it works seamlessly in any modern browser without the need for a server. It also stores your inputs and audit history locally, ensuring your data is ready whenever you need it. In this session, I'll cover the challenges this tool addresses, explain exactly what it calculates, walk you through the math behind it, and show how you can implement it within your quality team for quick, reliable gauge risk screening. Here's an important point: the same gauge can be perfectly fine measuring one feature, but completely unusable for another. This is because the %GRR, or gauge repeatability and reproducibility, is always relative to the tolerance, not an absolute measure. For example, if you have a very coarse tolerance of plus or minus 1.0 mm, a measurement variation of 0.05 mm barely makes a difference. But if the tolerance is much tighter, say plus or minus 0.1 mm, that same 0.05 mm variation can consume most of the allowed tolerance and become a serious problem. Now, formal measurement system analysis, or MSA, studies, like the AIAG Gage R&R, aren't performed on every single feature. These studies are complex, requiring careful planning, multiple operators, and several parts. As a result, most manufacturing drawings never get a full R&R study before production begins. Another challenge is that no one currently flags when there's a mismatch between the gauge capability and the tolerance grade specified. Engineers often select ISO 2768 grades, fine, medium, or coarse, based on drawing conventions without verifying if the shop's gauge can actually measure at the level that grade demands. Let me walk you through 2 scenarios using the exact same gauge on the same 25 mm shaft diameter, with 4 repeat readings each. In the first scenario, the feature is assigned a medium grade tolerance of plus or minus 0.300 mm. The total tolerance here is 0.600 mm. The trial range we observed was very tight, only 0.002 mm. After calculation, the equipment variation came out to 0.00118 mm, resulting in a %GRR of just 0.2%. This is well within acceptable limits, so the gauge passes easily. But in the second scenario, the same feature is assigned a fine grade with a tighter tolerance of plus or minus 0.100 mm. Total tolerance is now 0.200 mm. Even a modest trial range of 0.050 mm leads to an equipment variation of 0.02954 mm. When we calculate %GRR, it jumps to 14.8%, which is beyond the 10% threshold, marking this gauge as only marginally acceptable for this finer tolerance. What this shows is that the exact same measurement behavior can mean very different things depending on the tolerance specified. Unfortunately, today's drawings or spreadsheets don't automatically compare gauge capability against tolerance grade. Our tool fills that gap by instantly recalculating as soon as the grade is changed, providing live feedback on whether the gauge is truly suitable for the feature's tolerance. This ensures measurement reliability and helps avoid quality issues down the line. Let's walk through what this tool does every time it runs, starting with the Auto ISO 2768 tolerance lookup. The tool automatically calculates the bilateral tolerance band based on the nominal size and the selected grade, whether fine, medium, or coarse. It follows the ISO 2768 standard, applying step-up multipliers when the nominal size exceeds 30 mm and again at 120 mm, accurately reflecting how tolerance bands widen with part size. Next, the instant %GRR screening feature uses 4 repeatability trials on the same feature to determine equipment variation. It calculates the range between trials, converts that to equipment variation using the AIAG range method constant, and then expresses this as a percentage of the total tolerance. What's impressive is that this recalculates live with every input change. No need to press a run button until you finalize the record, keeping the assessment fluid and immediate. Now, the 3-tier verdict engine classifies the measurement system analysis risk automatically at set %GRR thresholds. A %GRR of 10% or less results in a pass with low MSA risk. Between 10 and 30% is classified as marginal risk, indicating moderate MSA risk depending on how critical the application is. Anything above 30% is a fail, indicating high risk and an unacceptable measurement system relative to the given tolerance. These thresholds align perfectly with established AIAG guidelines but are fully automated here. Finally, the full audit trail feature ensures every assessment is meticulously recorded. It logs the feature reference, trial readings, the basis for tolerance, and the verdict into a running table. This audit trail can be exported in CSV, JSON, or formatted PDF formats, all maintaining ISO 2768 and AIAG compliance. It also supports additional notes, operator details, and calibration info, ensuring full traceability and accountability in every measurement evaluation. Here's how the process works in 4 main steps, taking you from initial readings all the way to a logged, exportable report. First, we capture key information and trials. You enter the part or feature reference, the nominal size, the ISO 2768 grade, and the study type, like repeatability only or release check. Then, you input 4 repeatability readings from the same gauge on the same feature. Each of these fields updates calculations live, so you see results instantly without needing to submit anything. Next, the system automatically calculates the tolerance. Using the ISO 2768 standard, it applies size-based multipliers. The grade value is multiplied by 1.5 if the nominal size is above 30 mm, and by 2 if it's above 120 mm. This gives us a unilateral tolerance, which is then doubled to create a bilateral tolerance band. The third step is to compute and classify the %GRR, that is, the gauge repeatability and reproducibility percentage. We take the range between the maximum and minimum of your 4 trials, then multiply that by a statistical constant to get the equipment variation, or EV. Dividing EV by the total tolerance and converting it to a percentage gives us %GRR. Based on this value, we classify the results as pass if it's 10% or less, marginal between 10 and 30%, and fail if over 30%. Each category is visually marked with a badge color and gauge fill for clarity. Finally, you can log and export the results. Hitting Add saves the complete record, including all inputs, calculations, the verdict, and any notes, to an audit trail stored locally. This trail holds up to 50 entries and can be exported at any time in CSV, JSON, or a branded PDF report. The PDF includes a summary of marginal and fail counts, detailed record tables, and a compliance statement based on ISO 2768 and AIAG standards. This step-by-step approach ensures accurate measurement analysis and keeps a full audit trail for reporting and compliance needs. Let's talk about catching the gauge problem before it even reaches the production line. This tool screens measurement risk quickly. It only takes the time to enter 4 repeat readings, so there's no need for a scheduled study. It speaks the same language your quality team uses, incorporating ISO 2768 grades, %GRR, and clear pass, marginal, or fail verdicts. Every decision it makes traces back to the exact trial data and the tolerance basis behind it, ensuring full transparency. Best of all, it runs entirely in your browser and can be deployed to a shared drive or internet page in just an afternoon, no complex setup required. This is a screening aid designed to flag obvious issues fast. It's not a replacement for your formal MSA process but a helpful first step that builds confidence for quality engineers by catching problems early. To get started, bring 4 repeat readings from a real gauge and feature, and we'll screen it live together right here. If you'd like to book a working session or have any questions, feel free to reach out via the contact details on this slide or email us at info@mnqengineeringsolutions.com. Let's catch those measurement risks early and keep your line running smoothly.